So this is Geometry Semester 2, and it's the second unit, Special Right Triangles, and it's the fourth lesson, 45, 45, 90. The title of the lesson is Adj and Op Leg Practice. It's a little bit cryptic, it's abbreviated, right? Adj stands for adjacent and Op stands for opposite. So adjacent and opposite leg practice. It's on creatormath.com. It's under the Geometry tab. And you're going to scroll down until you find the unit on special right triangles and the fourth lesson here on 45, 45, 90 Adj and Op Leg. The instructions are to copy the following problems 1 through 7 into your composition book on the correct pages according to the table of contents, with the notes for those pages from creatormath.com. Do not forget the notes. The notes are on a separate link there on the table of contents. Open those up. That's going to explain to you a lot of background material for these problems. If you don't have that, you can watch this and maybe figure some things out, but you're going to need those notes to fill in the gaps. The first question is given a right triangle with one 45-degree angle, or one angle 45 degrees. The side length across from the 90 is 10. What is the length of the leg across from the 45 degrees? Well, first things first, we need to draw a 45-degree triangle, and mine won't be perfect, but pretty close. I'm going to put the 90 degree in the corner here. I'm going to label this 45 degrees. If this is 45 degrees, you guys, then this is 45 degrees. Why? Because 45 and 45 is 90. 90 plus 90 would be 180, and we know the rule that the sum of the angles of a triangle have to equal 180 degrees. So hence a 45, 45, that's why it's called this, 45, 45, 90 triangle becomes one of the special rights. Why is it special to us? And I'm going to draw this over here like a key. Pretend this is a map, and this is the key to the map. Well, the way a triangle works, if it's 45 degrees, 45, 45, 90, it's x, x, and x times the square root of 2. These ratios play out no matter how big or small the triangle is. So in this first problem, they're giving us a side length. So it says the side length across from the 90. So let's go across from the 90. That's this length here is 10. So this side here is 10 long. That's the hypotenuse. And they're asking how long is the leg across from the 45? Well, it's a little bit of a play on words because both legs of a 45, 45, 90 triangle are equal. So if you know this one, it's x. If you know this one's x. If this were 10 over here, this would be 10 over here. Now they're giving us the hypotenuse is 10. So the way we solve that is to put the 10 equal to the x square root of 2. Right? So we're going to take x square root of 2. Put it equal to 10, and then we're going to proceed to solve for the x. We're going to isolate the x. We're going to divide both sides by square root of 2. That's going to cross out and disappear from the left. Over here, we're going to do what's called rationalizing the denominator. Again, see the notes on creatormath.com for this particular lesson. This is 1, and we can multiply anything by 1, and it does not change the value. What it does is get this square root out of the denominator of a fraction. We do not like a square root in the denominator of a fraction. In fact, it's not allowed. So we have to do this thing called rationalizing the denominator. Multiply across the top, 10 square root of 2. Multiply across the denominator, square root of 4, which simplifies to 2. So we have 10 square root of 2 over 2. 10 divided by 2 is 5. So what we really have is x equals 5 times the square root of 2. Right, that's what x is. And since either leg, this one here is x, and this one here is x, and we found out it's 5 times the square root of 2, 5 radical 2. Now, another name for the square root symbol is radical. So this could be 5 times the square root of 2. This could be said 5 square root of 2, or this could be said 5 radical 2. Any of those are acceptable ways to describe that answer. Now, some students wonder, why do you keep the square root of 2 in there? What is the value of this, right? So a little bit hard to understand at first. This is my phone. Everybody has a standard calculator. If you turn your phone sideways, your calculator opens up to the expanded trig calculator. And in here I have a square root function. So let me just show you what square root of 2 is. Square root of 2 is 1 point, there we go, Square root of 2 is 1.4142135624. Now, we're not going to put that number in. That's way too messy. If we just leave it square root of 2, it means this answer. And this answer happens to be 5 times that. So think of saying times 5. Again, we're not going to put in 3.162277. We're going to leave it 5 times the square root of 2 because this is more accurate. Why? You'd have to truncate some of these numbers or cut off some of these decimal places if you just wrote the number. So we leave it 5 square root of 2. It's perfectly accurate, and we love that as math teachers and as math students. So that's why we have a square root of 2. In rationalizing the denominator, we use 1, and since there was a square root of 2 in this denominator position, we used square root of 2 over square root of 2. If you remember, the 30, 60, 90s had a square root of 3 in it, and then we used square root of 3 over square root of 3 to rationalize those denominators. So it just depends what's in the denominator for what you'll use to rationalize it. Given a right triangle with one 45-degree angle, I'm going to draw my 45, 45, 90s the same every time for you so that we don't have to worry about orientation. We can sort of get used to this. It says the side length across from the 45, that's over here, is 20. And if it's 20 here, by the way, and it's across from the 45, this is across from the 45 too, 20. And notice that fits our pattern. Our pattern is x and x for the 2 legs. And remember, a triangle has 2 legs like a human. And these are both the same because a 45-degree angle goes up at that 45. This is the same distance, same distance. This one's x square root of 2. So if we have 20 for this leg, then this one's 20 times the square root of 2. And that's it. This side's got to be 20 times the square root of 2. And that kind of freaks students out. They're like, that's it? I mean, this one was so complicated right here because we had to go backwards from the 10 to the leg. Once we have the leg, we can go forwards to the hypotenuse, and then it's a lot easier. So 20 radical 2. Given a right triangle with 45 degrees, by the way, on this lesson, they're all 45 degrees as far as I know, so it's going to look the same every time. They're giving us the length across from the 90 is 7. What's the length of either of the 2 legs, right? So we take this 7, place it equal to the ratio for that side, which is x times the square root of 2. X squared root of 2 equals 7. Now we solve for x. We divide both sides by square root of 2. And I'm going to multiply this by square root of 2 over square root of 2 to rationalize out this radical from the denominator. I'm going to get 7 square root of 2 on top. It just multiplies across. This one multiplies by each other for square root of 4. This becomes 7 square root of 2 over 2. Now all of ours have reduced before. Like we were literally able to reduce 10 divided by 2 came out 5. This one does not reduce. It just sits there. We don't have to be worried about this. We just go ahead and say 7 square root of 2 over 2. This is the value of x. And just to go back to the calculator 1 second, if we needed to say what that was numerically, we'd go 7 square root of 2 parentheses divided by 2, 4.95, right? But we're not. We're going to leave it more accurate in this form here. If this is what x is here and here, right? Equals 7 square root of 2 over 2. And this one also, 7 square root of 2 over 2. And 7 radical 2 over 2. This is written a little bit cryptic, right? I almost wish they had a parentheses maybe, but it does say 7 radical 2 divided by 2. 7 radical 2 divided by 2. That's the answer. Another 45. So 45, it's a right triangle. What is the measure of the leg across? Oh, they're just asking us about the generic. The generic is x squared root of 2. X squared root of 2, right? So what is the measure of either leg? It's x. This is a leg, and this is a leg. They're x. This one's asking the same question, but now moving to a different part. What's the measure of the side length across from the 90s? the 90 degree, which is the hypotenuse. Here's the 90, here's the 45. If this is x, this is x square root of 2, so x radical 2. And if you've done the prior lessons to this, you're going to see this is very similar, only we have switched to a 45, 45, 90 rather than a 30, 60, 90. So given the following 45, 45, 90, if a is 6, so they're saying this equals 6. And we called it x before, but we're calling it a now. And this is called a square root of 2, right? So what is the length of the hypotenuse? It's whatever a is. In this case, a is 6. 6 times the square root of 2. 6 square root of 2. Given the following 45, 45, 90 special right triangle, if the hypotenuse is 6, so now we're saying this equals 6, and I'm going to put it back in terms of x because I like it when solving. This says x square root of 2, that's what that says right there, and it's an a, but I'm going to change it to x because my a's start to look like 9s. I'm going to say this equals 6. Let's divide both sides by square root of 2. Multiply this by square root of 2 over square root of 2 to rationalize the denominator. 6 square root of 2 on the numerator position. Square root of 2 times square root of 2 is square root of 4. 6 square root of 2 over the square root of 4 is 2. 6 divided by 2 is 3. So we literally have x equals 3 square root of 2. That is the value of this right here. They called it a, I called it x. It's 3 times the square root of 2. So again, you're on creatormath.com, you're under the geometry tab, and you're down under the unit called special right triangles, and this lesson is lesson number 4. Find this one, and this is the video that links up with the assignment you have to do, and these problems go in your comp book on the appropriate pages according to the table of contents.